Yesterday we talked about direct variation. We saw an example where we had a job that paid $8 per hour. We made a table that showed the number of hours that we worked and the amount of pay that we would receive. We plotted those points on the graph and saw that they formed a straight line that passes through the origin. Whenever we have a straight line that passes through the origin, we have what we call direct variation. We saw that the slope of the line had another name. We called it the constant of variation. Today we're going to look at something a little bit different. In today's example, we're asked to build a garden that has an area of 36 square feet. Let's list some possible dimensions. We could have a length of 1 and a width of 36. Remember, area is length times width, which gives us our 36 square feet. We could increase the length to 2. The width would now be 18. Again, that would give us 36 square feet. We could increase the length again and make it 3. Notice that when we do that, the width becomes smaller. The width is now 12. If we make our length 4, our width again gets smaller, down to simply 9. And that continues along. 6 and 6, 9 and 4, 12 and 3, 18 and 2, and 36 and 1. Notice that whenever the length gets bigger, the width gets smaller. If we plot those points on the graph, we have something that looks like this. We can connect them with a nice curve, and we have what we call an inverse graph. This is a graph of an inverse variation. Inverse variation simply means that as x gets larger, y gets smaller. Notice on the graph, when x is really small, when x is 1, the y is way up at 36. Notice as x gets bigger and bigger and bigger, y gets smaller and smaller and smaller. When x was 36, for example, y was only 1. How can you tell the difference between a direct and an inverse variation? Well, there's a few things that are important to know about inverse variations. First of all, as we already saw, the two numbers have a constant product. In this case, it was 36. The graph always looks like this, and it will never deviate from that. Direct variation, on the other hand, is simply a straight line passing through the origin. If you see a problem, here's some keywords that you might run into. Y varies directly with x. Y is directly proportional to x. Remember, when you have a direct variation, the ratio y over x, the slope of the line, is constant. On the other hand, if you have an inverse variation, you might see things like y varies inversely with x, or y is inversely proportional to x. In these cases, the product, x times y, is the constant. In example 3, they tell us that the variables x and y vary directly. We're told that they want us to write an equation that relates x and y. Remember, the equation for a direct variation is a line y equals mx plus b. The first thing we'll do is find the slope of the line, or, as we call it here, the constant of variation. Y over x gives us the constant of variation, which is called k. We find that the value of k is 3. 3 is the slope of our line. We can now write the equation y equals 3x. It's really y equals 3x plus 0 because it passes through the origin, but we don't need to write plus 0. The second example is for you to try. Please use y over x to find the constant of variation, which is your slope, and then see if you can write the equation of the line. Please pause the video here and then come on back. We'll see how you did. In our example, our constant of variation is 5 over 2. 5 over 2 is the slope of the line. Y equals mx plus b. Y equals 5 halves x plus 0 because it passes through the origin. Please try example C. Pause the video and then come on back. We'll see how you do. In this example, we have the ratio y over x gives us 1 over 2. 1 over 2 is the constant of variation, and it's also the slope of our line. So we have y equals 1/2 x. Example 4 takes us into the world of inverse variation. We're told that the variables x and y vary inversely. As soon as you see that things vary inversely, you should think, okay, we have a constant product, x times y. The constant of variation with an inverse variation is x times y. In example A, we have x times y is 4 times 3. 4 times 3 is 12. Now, we know that x times y gives us k. And so, since k is 12, x times y equals 12. Now, because we typically like our equations to be y equals, we can divide both sides by x, and we find out that y equals 12 over x. That's the equation for the inverse variation. In example B, it's the same kind of thing. K is x times y. In this case, that's 6 times 8, which is 48. That means x times y equals 48. Whatever my two numbers, x and y, are, they'll always multiply to 48. Again, because we usually like y alone on the left-hand side, we'll divide both sides by x, and we'll end up with y equals 48 over x. Example C is for you to try. Please pause the video here, then come on back, we'll see how you do. Let's take a look. Here, we have k is 5 times 2/5. That means k is equal to 2. Because we have an inverse variation, k is x times y. X times y equals 2. We divide by x so that y is alone, and y equals 2 over x. We can have word problems that involve inverse variation. In our example here, it says the time for a car to travel between two cities is inversely proportional to the rate of travel. In other words, the faster you go, the less time it takes. It takes 5 hours to travel at 55 miles per hour. We want to know how long it takes at 65 miles per hour. So we fill in our formula. 5 times 55, that's 5 hours at 55 miles per hour, equals x times 65, that's x hours at 65 miles per hour. Now, we simply solve for x, and we find out that x is about 4.23. And so it takes approximately 4.23 hours in order to travel at 65 miles per hour. Our next example involves the speed of gears. The speed of a gear varies inversely as the number of teeth that it has. The fewer teeth, the faster it goes. If a gear has 45 teeth, it makes 24 revolutions per minute. That means it turns all the way around 24 times. They want to know if a gear has 36 teeth, how many revolutions will that gear make in 1 minute? At this time, I'd like to ask you to please pause the video, fill in the formula, and see if you can find the answer to this question, the number of revolutions per minute that a gear with 36 teeth can make. In this case, we have 45 teeth gives us 24 revolutions per minute. 36 teeth gives us an unknown amount. We'll call it y. 45 times 24 equals 36 times y. Solve the equation, y equals 30, which means the speed of the gear would be 30 rotations or revolutions per minute. We're going to end today by looking at a couple of last examples to determine whether it shows a direct or an inverse variation. Take a look at these graphs. Please pause the video here for 1 moment. See if you can determine whether each graph shows direct variation, inverse variation, or neither one. Our first graph shows neither. It looks like it could be a direct variation because it's a line, but we know that a direct variation must pass through the origin. Because this does not pass through the origin, it cannot be direct variation, and the graph does not have the right shape to be an inverse. So that one is neither. The second graph, B, has the shape of an inverse variation. Graph C is linear, and it passes through the origin, which means it's a direct variation. On the last example, example 2, they want us to determine whether each table shows a direct or an inverse relationship. When we do this, we're looking for one of two things. If y over x is always the same value for all of the numbers given, then it's direct. It has a constant slope. If x times y gives us the same amount each time, then we know that we have an inverse relationship. Let's take a look at the first one. If we take y over x, we get 5 over 2. Y over x, 10 over 4, which reduces to 5 over 2. 25 over 10, which also reduces to 5 over 2. And so, because we have that proportion, the values are constant that way, we have a direct variation because the ratio of y over x is always 5 over 2. In the second example, we do not have that constant ratio. But notice that 5 times 20 is 100. Also notice that 10 times 10 is 100. 25 times 4 is 100. And because x times y is always the same value, we must have an inverse variation. Please pause the video here and try the final two graphs. See if you can determine if these tables show a direct or an inverse variation. In the third example, we notice that x times y is always 36. Because x times y is a constant product, we know that we must have an inverse variation. Notice as x gets larger, y gets smaller. The last example, we have again a constant ratio. Y over x, 12 over 3 is 4. 20 over 5 is 4. 32 over 8 is 4. And so in this case, we have a direct variation. At first, it can be a little confusing to remember what to do with which. What you really need to remember is a direct variation is y over x. An inverse relation is x times y. Once you practice these a little bit, you'll feel much more comfortable with them. My recommendation is to take a few minutes now, browse back through the examples we did in the notes, take just a couple of minutes to do that, and then go ahead and write your summary for this lesson. This is all you need to get going with inverse variation and comparing direct versus inverse variation.